Part D, word problems, real world applications. Okay. So here we have it. A lot of times you guys think word problems are the hardest thing ever. Actually, they're usually the easiest problems. The hard part is you reading and you setting up from the situation. After that, it's the easiest problem typically. So the sales of lawnmowers 2 years after particular models is introduced is given by the function y equals 5,500 natural log of 9 times t plus 4, where y is the number of mowers sold. How many mowers will be sold 3 years after a model is introduced? Round the answer to the nearest whole number. Okay, so y is the number of mowers sold. T is your years. And what did they give us? They gave us our years. So they gave us our T. So in this case, all it simply wants us to do is what? Plug in, plug it in, plug it in. So we're looking for the y when t equals 3. See? You look at a word problem, you freak out. But in theory, is that terrible? Can we not plug that in and figure it out? I believe you can. So somewhat, approximately. Plug it in. Round to the nearest whole number. How many lawnmowers should they expect to sell in 3 years based on this model? What'd you get, Austin? 18,887. I think so. 18,887 lawnmowers, mowers coming their way. So that's what their model. Easy enough? So again, word problems, don't be intimidated. Read it fully, mark the text, and identify what your variables represent. Okay? All right. Let's do a bigger one. Okay? I'm going to give you a moment to read through it, identify what you think is key information, and then we'll go from there. Okay? So read and see what you can do first, and then we'll come back and talk. Okay, so first thing first, as you read through the problem, how many of you realize that this was just information, like facts? Like it wasn't going to be used for anything. So this is a fact. Okay. All right. Then the next thing it told you was your very, very important formula. So your max velocity for the rocket formula, you have V equals negative 0.098t plus c natural log of r. So from here alone, you should know that there are 3 variables you need. You need a t, you need a c, and you need a r in order to do anything with this. Okay. So you continue to read, and it said the ratio of the mass of the rocket filled with fuel to its mass without fuel is r, right? So suppose a booster rocket for a spacecraft has a mass ratio of about 15. So that's telling me my r. Exhaust velocity of 2.1 kilometers per second, and a firing time of 30 seconds. So plugging all that in, your C is your exhaust. So we have our C, and our C is 2.1, and our T is 30. So it literally was just another plug-in. Do we see that? Is that sometimes we get intimidated by the wording and we're like, oh my gosh, there's so much got to do, right? But no, you're just plugging in. So now it says equals. Well, we now know that T is 30. We now know that C is 2.1. We now know that our R is 15. So it's just a matter of plugging those values in. So reading, identifying, and plugging in. Okay. and then answering the question once we've had our information in front of us. So we're going to go to handy dandy calculadora. Where's homegirl Sylvie? Hey girl, here she is. Turn her on. And I'm literally typing it negative 0.0098 plus my C value. Oh, forgot my T. And y'all were just going to let me do that. Times 30 plus my C, 2.1 natural log of my R, and my R is 15. I hit enter and I get a value. My value I got is 5.393. So I know that based on these variables, we have V equals 5.393 kilometers per second. The question asks, though, can the spacecraft achieve a stable orbit 300 kilometers above Earth? Well, in order to have a stable Earth orbit, what would my velocity need to have reached? 7.7. This is less than 7.7 kilometers per second. So will I be stable? No stability. Does that make sense? All right. That is it.